Hey everyone! Before we get going, let's address the elephant in the room. Or should I say, the cow? Okay, that was bad. But without further ado, we're going to talk about absolute values and the transformations that exist. I'm sure you're to enjoy. Okay, before we jump into this fancy equation of y equals a times x minus h plus k, we have to start from the very beginning, which is called the parent graph. And the reason we call it the parent graph is because everything will originate from this graph. And it's a very, very simple equation that you notice here. It's y equals the absolute value of x. Has none of the a, has none of the h or the k. So it's the very, very essence of where everything begins. And a couple of things that you'll notice here, and we're going to graph this in just a little bit, but I'm gonna graph this by hand so get you an idea of what this looks like. The first thing that you'll notice here, it doesn't have any h or k value, so it always starts on what we call the origin. And then the other things you'll start to notice as I put some tallies on each axis is that each one of these graphs goes up 1 over 1 both directions. And we can kind of continue that trend up 1 over 1 on the slope and draw our lines. So the critical things that you need to understand about the parent graph, and just looking at the parent graph right now, okay, it always starts, or what we call the vertex point, is 0, 0, which is key. Its slope, both directions, always is up 1 over 1, both directions. And the other thing that you should notice is that it opens going upward. And that's key as well. We'll talk about that after a while, okay? So those are kind of the three things that you're going to notice here. This is the parent graph. It doesn't have the A, H, or K values around it. It's where everything's going to originate, because we're going to take this graph and we're going to shift it all over the place, or what we call transform in math. Okay, so to get started, what I'm going to do is we're going to look at the parent graph, and we're going to use this website called Desmos. And as I said, I graphed it by hand, but I kind of want to give you another idea of what this looks like here. So I'm going to type in y equals the absolute value of x. And notice right from the get-go what it does is it starts at 0, 0 like we mentioned. So I'm going to go ahead and dot that in. And notice the slope that it goes up 1 over 1 both directions. So we know that, okay? So let's start by looking at what I think is the most important value to begin with, which is our h value. And let's talk about how this affects our graph, because the a, the h, and the k are all going to affect our graph in some way or another. So let's type in another equation, and we'll add in an h value. So I'm just going to make up one, y equals absolute value x, and let's just do something simple, plus 2, and we'll close the absolute value off to make it look nice. Okay, so now let's really start to dive into what just happened here. If you notice, the graphs look almost identically the same, but it's got moved. And how many times did it get moved over? Oh, it got moved over 1, 2, which is kind of ironic because our number is 2. But the hardest thing I think for everyone to understand is that it's plus 2 and it moved to the negative direction. It went to the left. So the hardest thing to remember about the h value, it does move left or right, but I always like to say it's the opposite of whatever number it is. So in this case, it was a positive 2, so it's going to move left 2. So it's taking that parent graph and what we call transforming or shifting it left 2. So if I would do the same exact thing and add in y equals x minus 2, it would shift it to the right. Okay, so let's continue on here. So we talked about the h value. Let's talk about the k value this time. So the k value is always outside the absolute value, whereas the h value is always inside the absolute value. So once again, I'm going to type in y equals, and I'm going to do absolute value of x, and I'm going to close my absolute value off because the k value is always outside. And this time, let's just put plus 2 and see what happens. Okay, interesting. So if I take this and let's mark it up again, it looks like the same identical graph because it starts here as vertex. This one goes up 1 over 1, just like our parent graph does. But what you notice here, it got moved up 1, 2. Okay, which is almost the same as our number right here, which is 2. So what you notice about what we call the K value is it moves or shifts it up. So moves up or down. And I like to just state this, even though it's known here. It's the same. So meaning, see how this one's a +2? Well, it moved it up positive direction 2, which is different than the H value because it's always the opposite. Okay, so if we had -2 here, it would shift it down 2 spots. So it took the parent graph and shifted up, or it could take the parent graph and shift it down. Okay, so we've talked about the H value and how it moves it left and right and always opposite. Key point. We talked about the K value and how it moves it up and down. So the last thing we need to talk about is this thing called an A value, which gets kind of tricky at times, but it's not bad. All right, so let's just make an equation up again, and we'll keep it pretty simple to start. So we'll have y equals, and before we do absolute, let's put a 2 in front of it. So we'll go 2 absolute value of x, and we'll close our absolute out. So what did this graph do? Well, if you notice here, it got shifted a little bit different. The slope is different. It didn't move in terms of the starting point. It still starts at 0, 0. But on my parent graph, I go up 1 over 1. But on my new graph, I go up 2 over 1, up 2 over 1. So this 2 really just affects the slope of it. So what we call this is called a vertical stretch, or I like to call it, it's going to get skinnier. It's not as wide as the parent graph here. So what the A value does is it affects the slope. So, or what we call a vertical stretch, or we flatten out depending on that. So that's something good to talk about while we're here. How could we not make this so skinny, but how could we make this wider? So let's as we're kind of adventuring through this here, let's see if we can come up with an equation that would be wider. I'm going to take this one out so we don't get confused here. So I'm going to put a new one in here, and let's see if we can make a V that's wider. So let's talk about y equals, and this time I'm going to put a fraction in front. So 1 divided by 2, and then I'll shift it over here, an absolute value of x, and close it up. Oh, so look what happened this time. So now the A value affected it and it got wider. So if you notice here, this parent graph is up 1 over 1, as we talked about before, but the new graph is up 1 over 2, up 1 over 2. So if it's a fraction there that's less than 1, it's going to get wider. Okay? If it's a number that's bigger than 1, such as 2, such as 3 over 2, okay, it's going to get skinnier. So not necessarily just a fraction, but it has to be a fraction that's less than 1. It's going to make it wider, and then a number that's bigger than 1 is going to make it skinnier. Okay? Now, there's one other thing that we need to talk about with the A value. There's almost 3 effects that it has. It can make it wider, it can make it skinnier. There's one other thing that it can do. So let me erase this stuff so you can see what's going on here. And I'm going to move out this graph. Let's put one more thing in there. So what if we did this? What if we made it a negative number? Let's see how that would affect it. Let's just go with -2 absolute value of x, and we'll close our absolute value off again. So this time what it did, so you got your parent graph right here, up 1 over 1, nothing changed on that one. But now this time we're going down 2 over 1, down 2 over 1. So we still kept that idea of slope of 2, but the negative value actually flips, what we call flipping your V. Okay, so the A value can make it wider, it can make it skinnier, or it can even flip it. So now you have a good idea of how all this stuff kind of comes together. The A value affects the thickness or the skinniness of your V. The H value moves it left and right, always opposite. And then the K value is going to move it up and down. All right. So what I finally want to do is, what if we put this all together? So let's look at one last example of this all together. Like I mentioned, I wanted to piece this all together so we know how the A, the H, and the K all affect this. So looking at this example, we have y equals 3 times the absolute value of x minus 4 minus 5. So what I want to do is I want to put the parent graph in here first, because I really like, and I really think it's important that we understand the parent graphs where everything originates from, and it's really nice to see how it transforms from the parent graph. So we're going to go ahead and type in this parent graph here and get that idea. And then let's see how, if I put this all together, how it affected. Let's talk about that before though, okay? We know that this, because we just spoke about what the H value does, it shifts it left and right. So it should shift it to the right 4, because it's always opposite. Then my V should get shifted down 5, because it's the same. And then the 3, it's going to face upward, but it's going to become skinnier. So let's see if that actually works, and let's see if it actually happens. So we got y equals 3 absolute value x minus 4. It's really kind of fun. You can see in Desmos how it go ahead and starts shifting it. Okay, and then we need to add on minus 5. Okay, so now let's take a look at what we have going on. Let's mark up our graph here. So we started from the parent graph. Notice that it got shifted 1, 2, 3, 4. Okay, which is good because we were over 4 right there with that value. Next, it got shifted down 1, 2, 3, 4, 5, which is that value right there. And then finally, the slope should have been up 1, 2, 3 over 1, up 1, 2, 3 over 1. So now you see how we can combine all the shifts into one so that the absolute value gets transformed. And you know all the pieces in front of it as well. So hopefully this gave you an idea of how we can take the parent graph and relate it to all the pieces that exist in an absolute value equation. I truly hope you enjoyed this lesson, and if you have any questions, please let me know. Thank you.